Most of the fault in the power system lead to short circuit condition. When such a condition occurs, a heavy current is short circuit and flow through the equipment, causing considerable damage to the equipment and interrupt the service to the consumer. There is probably no other subject to great importance in electrical engineering than the question to determine short circuit current under the equipment in the power system depend upon the short circuit current consideration. In this chapter, we shall confine our discussion to fault current due to symmetrical fault. Symmetrical fault in the three-phase system. The fault on the power system which give rise to symmetrical fault current. Equal fault current in the line is 120 degree is called the symmetrical fault current. Symmetrical fault current. The three-phase line are brought together simultaneously into a short circulation condition. This type of fault give rise to symmetrical current. We call the fault current current with 120 degree displacement referring to the current IR, IY, IB, which is equal to magnitude of 120 displacement among them. Because of balanced nature of the fault, only one phase need to be consideration it calculation since condition in the other two phase will be similar. The following point may be particular noted. The symmetrical fault rarely occur in practice. In majority of fault are on symmetrical nature. However, in symmetrical fault calculation are being discussed in this chapter, enable the reader to understand the prevalence that short circuit condition present in the power system. The symmetrical fault is most severe and impose very heavy duty in the short circuit. Symmetrical fault जो होता है very heavy duty रहता है. Limitation of the fault current. When a short circuit occurs in any point of the system, short circuit current limited by imbalance of the system up to fault point, thus referred to the a fault occur on the feeder of F point. कोई अगर F point fault हो रहा है, then the short circuit current from the generating station will have a value limited by impedance of generator and transformer and the impedance of the line between generator and the point of fault. This shows that the knowledge of impedance of the various equipment and circuit in the line of the system is very important for the determination of short circuit current. तो शॉर्ट सर्किट करने लगी इम्पिडेंस रो नॉलेज जरूरी है. In many situations, the impedance limiting the fault current are large reactive. तो जो हमें शॉर्ट सर्किट करने की इम्पिडेंस वर्क करता है रिएक्टिव वर्क होता है. Such as transformer, reactor, generator. Transformer, reactor, generator, cable and lines are mostly reactive, but where the total reactance is calculated exceeds 3 times the resistance, the latter is usually neglected. The error introduced by assume the not exceed 5% percentage reactance. The reactance of generator, transformer, reactor, etc. is usually expressed in percentage reactance. To permit rapid short circuit calculation, the percentage reactance of circuit is defined in the if the percentage of total phase voltage drop in the circuit when full load current is flowing. Percentage of reactance. Percentage of total phase voltage drop. Percentage of total phase voltage drop in the circuit when full load current is flowing. The percentage reactance रे phase voltage रो rule रहुଛି phase voltage drop. The percentage of reactance is Ix by V into 100. Alternate percentage is also expressed in the kVA and kVH. Percentage of kVA into X by 10 into kVA square. Percentage of kVA into X by 10 into kV square. If X is the only reactance element in the circuit, then the short circuit current is given by ISC V by IX. I into 100 by short circuit current is V by voltage by impedance. I into 100 by putting the value of X. In short circuit current obtained by multiple full load current by 100. For instance, if percentage reactance is, if an element 20% of the full load current is 50%, then short circuit current 50 by 25 only when the element is circuit. It may be worthwhile to mention here the advantage of using percentage reactance instead of ohmic reactance of short circuit calculation. Percentage reactance value remain unchanged when are referred through transformer, unlike ohmic reactance which become multiple of divided by square of transformer C. This makes procedure simple and permit quick calculation. Percentage reactance and base kVA. It is clear that above that the percentage reactance of equipment depend upon kVA rating. तो परसेंटेज रिएक्टेंस कहाँ ऊपर डिपेंड करছে kVA rating ऊपर डिपेंड करছে. Generally, the various equipment used in power system have different kVA rating. Therefore, it is necessary to find the percentage reactance of all the element in common kVA rating. This common kVA rating is known as base kVA. The value of this base kVA is greatly unimportance may be. Impotence যদি দেখো equal to the largest plant equal to the total plant capacity or any arbitrary value होता है. The conversion can be effected by following relation. Percentage of reactance in base kVA is base kVA by rated kVA into percentage of reactance in rated kVA. The percentage of reactance in base kVA टा होचे percentage reactance base kVA by rated kVA. Base kVA percentage kVA into percentage reactance at rated kVA. Have the reactance of 10% at 20% kVA. The fact that the value of base kVA doesn't affect the short circuit current need to illustration consider three-phase transformer line operating 66 kVA and connected through the 100 kVA transformer with 5% reactance to a generating station bus bar. Generator is 250 volt with 10% reactance. The single line diagram of system. Percentage reactance. kVA into X percentage by 10 into kV square. At the high voltage terminal transformer, it will be shown that the whatever value of base kVA we may choose, the value of short circuit current will be same. Suppose we choose 2500 kVA as common base kVA. On this value, base value, the reactance of various elements in the system will be reactance transformer as 2500 kVA base in equal to 5 into 2500 by 1000 12.5. Reactance generation 2500 kVA base into 10%. Common base kVA 12.10. From the above, it is clear that it may be value of base kVA short circuit current may be the same. However, in the interest simplicity, numerically convenient value for the value of such kVA. Short circuit kVA. Although the potential at the point of fault is zero, it is normal practice to express the short circuit current in terms of short circuit kVA based on the normal system voltage at the point of fault. The product of normal system voltage and short circuit current at the point of fault expression is kVA is known as short circuit kVA. reactance. Percentage reactance as base kVA equal to base kVA by rated kVA into percentage reactance in kVA. Short circuit current equal to IS equal to I into 100 by percentage base kVA into 100 by percentage kVA. Short circuit kVA equal to base kVA into 100 by percentage kVA. Okay, short circuit kVA टा हमने बाहर करना. Reactor control of short circuit current with fast expanding power system. The fault level power available to flow into fault is also rising. The circuit breaker connected to the power system must be capable of dealing with maximum possible short circuit current that can be occur at their point of connection. Generally, the reactance of the system under fault condition is low, and fault current may be rise to dangerous high value. तो जितेबाला reactance है fault current low है may be rise dangerous to high. It is no step are taken to limit the value of this short circuit current. Not only will be the duty required of circuit breaker be excessively heavy, but also damage the line and other equipment will almost may certainly occur. In order to limit the short circuit current to value which the which the circuit breaker can handle, additional reactance known as reactors are connected series with the system with suitable point. Reactor are connected series with the system suitable point. A reactor is a coil of number of turns generates a large inductance as compared to. तो ये reactor जो होता है large number of. A reactor is a coil number of turns designed to have large inductance as compared to ohmic resistance. The force on the turns of these reactors under short circuit condition are considerable, and therefore winding must be solidly brushed. It may be added due to the very small resistance of reactor. Reactor is very small resistance रहছে. Large inductance रहवा. Large inductance रहवा reactor रे. किंतु small resistance रहवा. Reactor is short circuit condition रे. It may be due to very small resistance of the reactor. There are very little change in effective the system. Reactor limit the flow of short circuit current. जो reactor रहता है limit the flow of short circuit current. Thus protect the equipment from overheating as well from the failure of due to destructive mechanism. For trouble are localized or to isolate at the point where they originate without communicating their disturbing effect to other part of the air system. This increases the chances of continuity of supply. They permit the installation and power breaker of lower rating. Location of the reactor. Short circuit current limit the reactor may be connected in series with the each generator. In series with each feeder in busbar, no definite statement can be given as to which one of the above location is preferable. Each installation has its own particular demand, which must be carefully considered before a choice of reactor location can be made. Generator reactor. When the reactors are connected in series with each generator, they are known as generator reactor. When the reactor are connected series with ଯେତେବେଳେ reactor ମାନେ connected रहे series with each generator, they are known as generator reactor. When the reactor are connected series with each generator, ଯେତେବେଳେ reactor ମାନେ connected रहे series with each generator, they are known as generator reactor. In this case, the reactor may be considered as a part of leakage reactance of generator. Hence, its effect to the protect the generator in case of short circuit beyond the reactor. There is a constant voltage drop advantage, disadvantage in the reactors. There are constant voltage drop, power loss in the reactor even during normal operation. Power loss is in normal operation. If busbar or feeder fault occur close to busbar, the voltage at the busbar will be reduced to low value, therefore causing the generator to fail out of step. If the fault occur any of the feeder, the continuity of supply to other like to be affected. Due to this disadvantage, also since modern power station generators have sufficiently large leakage reactance to protect them against the short circuit, it is not common practice to use separate reactor for generator. Federal feeder reactor. When a reactor are connected series with each feeder, they are known as feeder reactor. feeder reactor ବୁଝିପାରିଲ प्रत्येक reactor ଯଦି feeder से connect ହେଲେ since most of the short circuit occur on feeder, a large number of reactors are used for such condition. Two principal advantages claimed for feeder reactor. Firstly, if a fault occur on any feeder, the voltage drop in reactor will not be affected the busbar voltage, so that there is a little tendency for generator to lose synchronizing. Secondly, if the fault on the feeder will not affect the other feeder and consequently the effect on the fault are localized. There is a constant power loss and voltage drop in reactor even during normal operation. There is a constant power loss and voltage drop. There is a constant power loss and voltage drop in reactor even during normal operation. If a short circuit occurs at the bus bar, no protection is provided in generator. If short circuit occurs on the bus bar, no protection is provided to the generator. However, this is little importance because such faults are rare and modern generators have considerable leakage reactance to enable them to withstand short circuit across their terminal. If a number of generators is increased, the size of feeder reactors will have to increase to keep the short circuit current within the rating of feeder circuit breaker. Busbar reactor. The above two methods of locating reactor suffer from the disadvantage that there is a considerable voltage drop and power loss in the reactor even during normal operation. This disadvantage can be overcome by locating the reactor in the bus bar. There are two methods of this purpose, namely ring type or type bus ring type. In this system, bus bar is divided into sections and these sections are connected through reactor. Generally, one feeder is fed from one generator only. Under normal operating condition, each generator will supply its own section of the load and very little power will be fed by other generator. This result in low power loss and voltage drop in the region. Low power loss. This low power loss and voltage drop in the reactor. Ring low power loss and voltage drop reactor. However, the principal advantage of this system that if the fault occur any feeder, only one generator to which the particular feeder is connected mainly feed fault while occurrent from the other generator is small due to presence of reactor. Therefore, only that the section of bus bar is affected to which the feeder is connected to section of the continuity of normal operation. Tie bar system. So the tie bar system, compare the ring system with the tie bar system. It is clear that the tie bar system there are effectively two reactors in series between section. Two reactor series between the section so that a reactor must approximately half of the reactance which used in the comparable ring system. Another advantage of tie bar system is that additional generator may be connected to the system without requiring the change in the existing reactor. However, this system has disadvantage that it requires additional bus bar, the tie bar. Step for symmetrical calculation. It is already been discussed that the three-phase short circuit current result as symmetrical fault current in the three-phase system are equal in magnitude but displace 120 degree electrical from one another. Therefore, problem involve such fault can be solving by consider one phase only at the same condition prevail the other two phase. The procedure for solution of such fault is draw a line diagram of complete network, indicate the rating, voltage and percentage of reactance of each element of the network. Choose the numerical convenient value of base kVA, convert all percentage reactance into a value corresponding to the single line diagram of the network. Draw the reactance bus bar one phase of the system to the neutral. Indicate the percentage reactance to the base kVA in the reactance diagram. The transformer in the system should be represented by reactance in series. The transformer in the system should be represented by reactance in the series. Find the percentage reactance of the network up to fault. Let's be percentage x. Find the full load current corresponding to the selected base kVA and normal system voltage at the fault point. Then the various short circuit current is I into 100 by percentage x. Short circuit current is equal to I into 100 by percentage x. But short circuit KVA means base KVA into 100 by x. Base KVA, short circuit base KVA into 100, base KVA into 100 by percentage of x.